good evening, everyone. We began our discussion this evening with the definition of what we call polygons. So it says here you can read a polygon is a plane figure formed by three or more segments such that each segment intersects exactly two others, one at each endpoint, and no two segments with a common endpoint are collinear. So let us first dissect the meaning of the term polygon. So when you say polygon, it is a plane figure. And we know that because, as what we've mentioned before, what we're trying to discuss this quarter are plane figures, plane and solid geometry. And it is formed by how many, at least how many segments? It says here three or more segments. So which means to say the least polygon that we can form has at least or has three segments. But what's the relationship of those segments? So let's continue. It says here such that each segment intersects exactly two others. Now, look at the given polygon here in the example. So this polygon has how many segments? Let us see. First, I will draw the points of intersection. So you can see here A, B. Okay, we have C. You have here point D and point E. How many segments are there? So let's count. First, we have segment AB. That's one. Segment BC. That's two. Segment CD. 3. Segment ED. 4. And the last, it's segment AE, which is 5. So there are 5 segments. It says here, each segment intersects exactly two others. Let us see. Now, the intersection happens one at each end point. So, focus on segment AB. How many more segments does segment AB here intersect? You're right, there are two other segments. What are those segments? As you can see, you have this segment here which says 1 at each endpoint. The endpoint of AB are A and B, points A and B. And AE here or EA intersects AB at this endpoint. On the other hand, segment CB intersects AB at this endpoint. That's the meaning of that part. And the last, and no two segments with a common endpoint are collinear. When you say collinear, they belong in one line. So we're referring to, again, to AB. No two segments. It says here no two segments with a common endpoint. So that means, let's, for example, say AB and AE because they fit the description. They are two segments with a common endpoint. And as you can see, they should not be collinear. So in this case, are segment AB and segment AE collinear? The answer is no. So in that case, this plane here represents or passes as a polygon. So those are the things that you should consider when we're talking about polygons. And another thing. Okay, so first we will try to erase. Okay, let's clear the page. Sorry. Let's just clear the ink. Okay. Now, let's try to identify some parts of a polygon. Okay. So this polygon, as what we mentioned, is having 5 sides. So again, I will write these points here: A, B, C, D, and E. By the way, these points are called vertices of the polygon. So take note of that. There are 5 vertices here. Now, let's begin with some of the terms. With 5 vertices, you could also see 5 angles. So, first angle, angle A, B, C, D, and E. I hope you can see those angles. First up, I will discuss consecutive angles. From the term itself, it says consecutive, which means that these are angles that are next to each other. So, can you name consecutive angles from the figure? Correct. You have angle A and angle B. They're next to each other. What else? Angle A and angle E. This is also an example of consecutive angles. And we have many more. Okay, what about when we talk about consecutive sides? Just like consecutive angles, this also means that two sides that are next to each other. So, in our example, we have this side AB. What could be a side that is a consecutive side to side AB? You're right. You have side BC. You could also say that side AB is consecutive sides with side AE. Now notice that if they're consecutive sides, there's a common endpoint that you can find on the two sides. Okay? Now, to continue, let's try what about if we talk about included angles? What are included, or I mean, sorry, included sides? From the term included, it means to say it's between two angles. Again, I repeat that. When you talk about included sides, these are sides in between two angles which are consecutive. So, for example, let's try angle A and angle B. You see here angle A. This is angle B. You have here a side that's between angle A and angle B. These two are consecutive. This side is the included side of angle A and angle B. So for angle A and angle B, the included side is segment AB or side AB. What about for angle A and angle E? The included side is segment, okay, angle A here, angle E here. So this is the included side, angle AE. Alright? Now, what have you observed? If you have included angles, I mean if you have two consecutive angles, the included side is actually just the vertices of these two consecutive angles. That's something that you should observe. Next, what about included angles? When we talk about included angles, just like included angles now are those angles in between two consecutive sides. So let's see. Remember, we have consecutive sides here. Sorry, this is point T. Okay, let's check this one. AB, side AB, and side BC. Where is side AB? Side AB is located here. Side BC is over here. Do you see this angle right here? It's angle B. That is your included angle. So, for side AB and side BC, the included angle is angle B. Alright? What about side AB and side AE? So AB is here, side AE is here. This is your included angle, which is angle A. I hope I made the explanation clearer, and I hope that you understood how to illustrate these parts of a polygon. Now, down to the last part, which we call diagonals. When you talk about diagonals, this is a segment that is drawn from one vertex to another vertex which is not a consecutive vertex. So for example, this is point A. I will draw this segment from A to C. This is a diagonal. I can draw another diagonal from A to D. That's another diagonal. So from point A, I can draw two other diagonals to these 2 points because A and C are non-consecutive vertices, as well as A and D. If I'm coming from point B, the diagonal that I can draw is from point B to E, and another one is to D. Alright, if I'm coming from point C, the diagonal that I can draw is C to E and C to A. If I'm coming at point D, I can draw a diagonal from D to B and D to A. And yes, it looks like a star. Alright, so I hope you can see how the diagonal work. It's just a segment connecting two non-consecutive vertices in a polygon. Moving on. A polygon has regions. So, regions. There are actually 3 regions in a polygon. The first one is, of course, the interior right here. And the exterior should be outside. And the region which is exactly on the polygon is this part here. Now, when we're talking about polygons, the polygon could either be, the region could either be moving inwards or not. This is the case of what we call concave and convex polygon. But before that, when you talk about polygons, if all the sides here are congruent or equal, if all the sides are congruent or equal, it becomes a regular polygon. So once again, what are regular polygons? These are polygons with all sides congruent, or all sides measures the same. So it said that it starts from a 3-sided polygon. So it begins with an equilateral triangle. Not just any kind of triangle, equilateral. Because remember, all sides should be congruent. If it has 4 sides and it's regular polygon, it's called a square. You can just say, you cannot say rectangle. Rectangle is not a regular polygon because the sides are not all sides are congruent. If it has 5 sides, it's called a pentagon. And our example earlier is pentagon. What about if it has 6 sides? A regular polygon with 6 sides is called hexagon. To continue, if it has 7, it's heptagon. If it's 8, it's octagon, 9, nonagon, and 10, decagon. So for the rest, if for example, it's more than 10 sides, we simply say, we base it on the notation n-gon. So if it's 11 sides, which is a regular polygon, we call it 11-gon, 12-gon, 13-gon, and so on and so forth. Now, going back to what I said earlier, a polygon could have sides that are pointing inwards, and those polygons are called concave polygon. So like in this example, this polygon here has sides that are pointing inwards. This one as well, it points inwards. And we call that concave polygon. Now, for those polygon that does not have this property, they call it convex. And in our discussion of polygons in this chapter or in this quarter, we will deal with these polygons here, the convex ones. And you have in your book a more detailed definition of concave and convex. But in this example, you can see it right away that in this case, we have here polygons that some of the sides are pointing inwards, or their diagonals. Some diagonals are outside the polygon. So like for example, this one, to connect it here, the diagonal of this polygon is outside the polygon. Okay, so like in this example, the diagonal could be here, which is outside. Whereas here, all diagonals are inside the polygon. Okay, so we begin our discussion with polygons on triangles. And tomorrow, we will deal more with triangles, but we knew before the types of triangles from our discussion in our grade school geometry. Triangles, the types are divided into two. We base the triangle in terms of angles, and in terms of sides. Now, when you talk about triangles in terms of angles, we have three. First is acute, second is a right triangle, and the third is obtuse. But let's look at them deeper. When you talk about acute triangles, the triangle has all of its angles. Remember, there are three angles in a triangle. If it's an acute triangle, all of the angles in the triangle are less than 90 degrees. Or in short, all of the angles there are acute angles. If it's a right triangle, only one angle is a 90-degree angle or is a right angle. So here in this example, this is your right angle here. No other angles here could be right. Now, if I ask you, what do you think are these angles here? Are they acute or obtuse? Okay, correct. They should be acute. Can any one of these two angles here be obtuse? No. So, one right angle in a right triangle and the other two should be acute. What about if it's an obtuse triangle? If it's an obtuse triangle, only one angle is obtuse. The other two should be acute. So you have here, obtuse triangle, one angle is greater than 90, or obtuse angle, and the other two angles should be acute. Okay, now what about if it's based on sides? We have the following. First, equilateral triangle. When you say equilateral triangle, the sides are congruent or equal. Next, isosceles triangle. In this kind of triangle, only two sides are equal, and the third one is not. Because if this would equal to the other two, it goes back to the equilateral triangle. And the last one is called scalene triangle, when no two sides are equal, which means to say all three sides of the triangle measures differently. Alright, now, what are the parts of a triangle? Now that we know that a triangle has two types, when we name it, it's either based on angles or based on sides. Question now, what are the parts of a triangle? First, we will discuss primary parts, because there are other parts which are called secondary parts, and that's what you're going to discuss with your group tomorrow in our group activity. When you talk about primary parts of a triangle, we refer to number one, angles, and number two, the sides. So in this triangle, we need first to name the triangle in order to identify its angles and its sides. So if this is triangle ABC, what are the angles? So first, we have angle A, we have angle B, and we have angle C. What about the sides? How do you name them? So our sides are the following. We have side or segment AC. Okay, we also have segment AB and segment BC. Now, all the other parts of the triangles will be discussed tomorrow. So, go over again this video and try to recall and try to familiarize yourselves with first the definition of a polygon, the different parts or of a polygon, the regions, what's concave polygon, what's a convex polygon, and of course your triangles. So up to here only. We see each other tomorrow. And bring your compass and protractor so that we could have a thorough discussion of the secondary parts of a triangle. So once again, thank you and goodbye.